Hello students, welcome to the class. Welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. And today we are going to do top 20 questions, top 20 very good yet easy but slightly twisted questions, doable questions of JEE Mains, right? Okay. So everybody let me know in the comment section if I am clearly visible and audible to you so that we can start with the session. It is a very important session if you actually want to trick your brain. Now, the session is not going to be really long, right? It's a very short session. Just 20 questions we are going to do here. But I want to see the full energy in the comment section, in the chat box, full energy, right? So that I can get to know if you are also having your notebook and pen with you so that you can solve this along with me. All the 20 questions. And you have to tell me in the end 20 out of 20 how many questions you got right. Okay, I'll see that in the end how many questions you got right in the end, and according to that you can also test yourself. Okay, so this is from full chemistry only, so you don't need to worry about that. Let us start without wasting any time. Okay, shall we, everybody in the chat box, shall we start? Okay, so let us start the class. First question is, decomposition of H2O2 follows a first order reaction. Very important. All are important questions only, right? Decomposition of H2O2 follows a first order reaction. Okay, this follows first order reaction, right? Decomposition of H2O2, that means H2O2 decomposes to H2O plus O2, right? Okay, in 50 minutes, the concentration of H2O2 decreases from 0.5 to 0.125. Okay, this concentration decreases in 5 minutes. Sorry, in 50 minutes. Okay, this happens in 50 minutes. Right? It is not a direct formula based question. That is why I have picked it here. Right? Next is in such decomposition, when the concentration of H2O2 reaches 0.05, the rate of formation of O2, what it will be, right? So we will start from this part, that 0.5 to 0.125, right? When you divide it, 0.5 divided by 2, that is 0.25. 0.25 divided by 2 is 0.125. That means 2 half lives are needed to convert 0.5 to 0.125. So we can clearly say that this to this happens in 2 half lives. So answer will be, this is 2t half equals to 50 minutes, right? 2t half equals to 50 minutes. If you have t half, then t half you can easily calculate from here. T half will come out to be 25 minutes. Understood? T half will come out to be 25 minutes. Once you have calculated T half, you can easily calculate the value of T half we have calculated. After that, we can calculate the value of rate constant. Right? Rate constant will be 0.693 divided by T half. You know the formula of rate constant. Right? T half is equals to 0.693 divided by rate constant. When you put this in this formula, you get the value of rate constant here. Right? Once you get the value of rate constant, now we will start with the very important part to calculate the rate of H2O2. Now from the rate law expression, we know that this is rate of H2O2 is equals to K multiplied by the concentration of H2O2. For first order reaction, rate of H2O2 will be equals to K multiplied by the concentration of H2O2 because it is a first order reaction. Understood? Because it is a first order reaction, so it will be K into H2O2. When we put the value of K here and we put the value of concentration, that is also mentioned here. When the concentration of H2O2 reaches 0.05, right, that you have to tell. So you'll put the value as 0.05. This is the value of rate constant. You will get the rate of the reaction, right, according to the rate law expression, right? So you got the rate of the reaction of H2O2. Now, very important point, because in this question you have so many things. You have rate law expression, you have rate of reaction, rate of disappearance, the formula they have also asked. They have also asked the value of T half and 0.069. Everything they have asked here. So that is why this question automatically becomes a very interesting question. Okay, so here it will be, as you can see the reaction here. In this reaction, the decomposition reaction, when you balance it out, now what we have to find out is the formation of rate of formation of O2. Right. So, ma'am, how did you got this expression? Ma'am, how can you directly get this expression? That is the major point here. Right. So, I'll tell you how we got this expression. Now, beta, if you focus on this thing, this is H2O2. Talking about the rate of reaction in terms of H2O2, that will be minus half of disappearance of H2O2 divided by dt. Okay? Because it is getting disappeared. Right? In terms of O2, it will be plus 1 divided by 1 d of O2 divided by dt. Right? So it will turn out to be, if you see this thing here, this thing will be, this is nothing but rate of disappearance of, see, one very important thing, whenever you are calculating the rate of reaction, you have to divide it with the number of moles. So number of moles is 2. So I am equating the rate of reaction according to H2O2 and according to O2. Right, so that is why I divided it by the number of moles. Here number of moles are 2, so I divided it by 2. Here number of moles are 1, so I divided it by nothing but 1 only. Right, but because of disappearance, here you have minus, because of appearance you have plus. But rate of disappearance and the rate of appearance is without the division with the moles. So this is nothing but rate of disappearance of H2O2. That means the rate of H2O2 you can say, right? This is nothing but this is the rate of H2O2, right? So you can just directly write as rate of, wait a minute, oof. Sure. Let us write it as rate of H2O2. This is nothing but this is the rate of, so that is why we have equated this rate of O2 is equals to half of rate of H2O2. That is how we got this formula. Is that clear? When you have rate of reaction, you have to divide it by number of moles. When you don't have rate of reaction, you don't have to divide it by, when you have simple rate of appearance and disappearance of a particular reactant or product, then you don't have to divide it by number of moles. So that is why R2 becomes half of R of H2O2. Then R of H2O2 you have calculated here, put this in the formula and you will get in mole per minute, right? This is what you will get here, right? Understood? Understood everybody? Next question, question number 2. They have given us this question that where you have a diene, not diene, you have a ene, you have a alkene that is getting reacted with Br2CCl4. So whenever you have a double bond that is getting reacted with Br2CCl4, always there is the formation of this cyclohalonium ion, right? Basically a cyclic intermediate is formed here, right? So in this cyclic intermediate, what happens? Now, why this question is very interesting? Because what we will think that these two, this pi bond will break and here you will have Br. This is what we will think. Here you will have Br and Br. But this is not the correct answer. In reality, what will happen here? Let us discuss that. Okay? Let us discuss. So, what will happen? Pi bond will break here and here you will have Br and here you will have Br. This is positive. Right? Now the electrons will jump here and what you will have? The electrons will jump here. Then what will happen? This Br will be as it is. This pi bond, so already it is not there. Right? Now here you will have the positive. This positive and this negative. It will attack here and it will form a cyclic structure. Right? That is why this question becomes very important. That here you will have oxygen 1, 2, 3, 4, 5, 6. Okay, so both are 6-membered rings. So this is eliminated, this is eliminated. Out of this, we have to choose. Right? So if you choose this, we know that if I take it, this is 1, this is 2, this is 3, 4, 5, and 6. On 6th position, I have one methyl. and I have one CH2Br. Okay, so this will be, if I start from here, this is 1, 2, 3, 4, 5, 6. On sixth position, you have one methyl and one CH2Br. If you talk about here, it is 1, 2, 3, 4, 5, 6. On sixth position, you have one Br and one CH2CH3. So this is not the correct answer. This will become the correct answer. Clear? Okay. Next question. Next question is, let us see that. Now, why this question is very interesting and very important. First is, these kind of questions they have asked already in attempt 1. Right. Second is, why this becomes so important? Because in one question, they are asking you multiple reactions. Right. That is why they are checking so much knowledge. Right. That is why this automatically becomes important to you. So one by one, let us see. Firstly, benzene is reacted with HNO2 and H2SO4, which is the nitrating mixture. So here you will have the addition of NO2 positive electrophile on any position because all are symmetrical in nature, right? So NO2 positive electrophile is here, and now we have nitrobenzene. Now we have H2PD, that means we are doing the reduction here. After reduction, what will happen? This O2 will be converted to H2, so you will have NH2 here. Once you have aniline, then when you react this with NaNO2 and HCl, this is diazotization. Diazotization. In diazotization, beta, what you do? In diazotization, what you do? This NH2 is converted to diazonium chloride, that is N2Cl negative, N2 positive, Cl negative. After this, we are reacting this with CuCN, right? That means the kind of Sand-Mears reaction, right? So this CN will attack here, and you will have the formation of cyanobenzene, right? Now, after this particular point is very important, that when you react this with Grignard reagent, here you have C triple bond N, right? When you react this with a Grignard reagent, I think there is some kind of lagging. I don't know why. Hana? I don't know why. I'm so sorry. I don't know why there is lagging here, right? So please adjust, right? So here it is MgBr, right? If you see this is nothing but this is positive. This will be positive, this will be partially negative. So here also this will be partially positive, this will be partially negative. So this is going to attack here, right? Electrons are going to jump here. So here you will have, with this carbon, you will have the addition of this methyl, right? Electrons will jump here, and this MgBr will get attached here, that is MgBr. After the hydrolysis, this whole thing is getting converted to double bond O, and hence in the end you will have the formation of ketone, right? Okay, is that clear to everybody or not? Is that clear? Students, is that clear or not? Okay, next we have AX is a covalent diatomic. Now what he is saying? AX is a covalent diatomic molecule where A and X are second row element. Second row element, okay. Second row element means this can be your buck no funny, okay. It can be this thing, right, which is the second row element of periodic table. Based on the molecular orbital theory, the bond order of AX is 2.5. Okay, the total number of electron in AX is round off to the nearest number. Now they are saying it is a diatomic molecule. Okay, it is a di, and these E and X are different. Okay, so it cannot be O2. O2 is also not 2.5, it is 2, right? So here the only option we are left with is NO. So NO is a diatomic molecule, right? Which is having, this is diatomic molecule, covalent diatomic molecule, which is having, if you talk about the bond order here, this is having how many electrons? This is having 7 plus how many electrons? This is 8, total 15 electrons. If you talk about the trick here for bond order, just directly solve this with the help of trick. This is 14 is 3, 15 is 2.5. Okay, 13 is also 2.5. So that means for 2.5, you need to have either 13 electrons or you need to have 15 electrons, right? So now in NO, you have 15 electrons. So answer is going to be number of electrons is 15 electrons. Otherwise, also the answer could be only 13 or 15. Out of 13 and 15, 13 is no possibility here. Even if you are trying to choose anything here, the only possibility that we have is NO, right? So answer will be 15 electrons with NO is the correct answer. Okay. Next is you have this compound where what we are doing, basically we are making from this to this and they are asking you the reagent. So whenever there is a question that they are asking based on the reagent, there also you have to think a lot, right? Why? Okay. Firstly, let us see, you have to form from double bond to directly CHO. Directly PCC will not work. If you have BH3 THF, what you will have? It will follow anti-Markovnikov rule. Anti-Markovnikov rule, beta, what do you mean by that? That means the negative part on more number of hydrogens. Negative part on more number of hydrogen means this pi bond will break and here you will have OH, right? After that, if you use PCC, which is a mild oxidizing agent, this will convert primary alcohol to aldehyde, right? So you need to have primary alcohol here, right? That means we can use BH3, that is hydroboration-oxidation. So that means A will turn out to be the correct answer here, right? Okay. Next question, let us see. Here, beta, you have from organic chemistry, these kind of questions are extremely important. Grignard reagent questions, they are extremely important. So here there is saying there is some A which reacts with Mg, then it reacts with methyl benzoate, then you hydrolyze it, then you get this thing. See, whenever you have a direct reaction, reactant is given, you have to predict the product. That is still easy. But when they have given us the product, you have to predict the reactant, you have to go in a reverse manner, which automatically becomes a little tricky, even if the question is easy. Even then, you have to think a lot to understand what exactly could be the answer. By this Mg, and because I can clearly see that there is some Grignard reagent formation here, right? So that means I need to have a halide here. So this and this are automatically ruled out, right? So I need to have which thing? Either bromobenzene, which looks like this, right? Bromobenzene, or I can have benzyl bromide. Beta, now even if you don't know the answer, even then you can answer this. Okay? Even if you don't know the answer, even then you can answer this. How? Firstly, you will have the reaction of bromobenzene with the Grignard reagent, right? Then you will have the form with Mg, you will have the formation of this Grignard reagent. Okay? Now, this is your methyl benzoate. Okay? What is benzoate? This is benzoate. Benzoate means ether you will have. C double bond O. I'll just write it like this. Okay? Chalo, let's write it over here only. Okay? I'm writing it here. That how can you predict? Okay? So how I predicted? If you see this here, methyl benzoate is C double bond O, OCH3. Right? As you can see here, methyl benzoate, then you hydrolyze it. You need to have 3 benzenes, na? So, methyl benzoate. This should be. Chalo, we'll try it. I think so that it should not be like that. But chalo, let's see. Okay. When you react this with bromobenzene, I think there is some typing mistake. Okay. When you react this with bromobenzene Grignard reagent, that is on benzene, you have MgBr. What will happen here? This is the positive part. This is the negative part. Here we know that this is the positive part. This is the negative part. So the negative part will attack here, electrons will jump here, and hence what you will have in the end. Acha, there will be hydrolysis also. This is benzene, this is C, this will be OH, this will be converted to OH. Here you will have the addition of this, and here you will have OCH3. Okay? Here you will have OCH3. After that you will do hydrolysis, right? So here CH3, PH, it should be benzyl benzoate. Okay, so it should be phenyl benzoate here. Only then you will be able to answer this now, right? So there's a little mistake here, what I can see, right? Okay. Achha, even more hydrolysis we are doing now. Okay, do one thing here. Okay? When you have a situation like this, right? Then again, if you say uh, this one more molecule of this attack here, then you can have the formation of three. This here, this is OH, this is PH, this is PH, and this is PH. So the only value that I can see here is bromobenzene, right? So bromobenzene have to react Grignard reagent, and then you will got to have the formation of this with the formation of Grignard reagent when it reacts in a form where it attacks the carbonyl carbon here. Okay, where it attacks the carbonyl carbon here. There it will be the answer. Okay, understood? Acha. Now, let us see the next question here, that is based on the correct increasing order of instability of this. Now, beta, again, this question is based on which thing? You have C2, 2 negative, O2, 2 negative, N2, 2 negative. So, here what you will do? Let us see that, okay? Now, the correct increasing order of stability, you have this thing, you have this thing, you have this thing. If you calculate the bond order directly, this is C into 2, carbon is 6, 12, 12 plus 2, 14. This is the oxygen is 16 plus 2, that is 18. Nitrogen is 14 plus 2, that will be 16. For 14, you will have 3. For 18, you will have 1. Because see, for 14, you have 3 bond order. For 15, it is 2.5. For 16, it is 2. For 17, it is 1.5. For 18, it is 1. Okay. So, answer will be 18 is 1, 16 is 2. Okay. So, if you see this, this is going to be 3, 1, 2. And here we are going to just put this value here, that is 3, 1, 2. So, that means the more stability is of C2, 2 negative, right? Okay. Then you will have N2, 2 negative. Then minimum is for O2, 2 negative. They are asking you the increasing order. That means O2, then N2, then C2. So, answer will be D is the correct answer. Okay. Next. Next we have N2O4 dissociates to NO2. Now you have N2O4 that dissociates to NO2 according to the following reaction, right? Now here what is it? See, in every question you will see something is important, right? So here what you have, firstly though they are saying that this is getting dissociated to NO2 according to the following reaction. Delta G you have to calculate, right? But they have given you something about 50%. That means alpha is given to be 50%, right? Alpha is given to be 50%. That means 0.5 alpha is given to you. If alpha is 50%, that means 50 by 100, that is 0.5, right? So alpha is given to be 0.5. That is given to us. Now what you have to do, just do this as equilibrium says. So 1, you will take this as 1. Initially this is 0, right? So from this you have to subtract stoichiometry multiplied by the dissociation, degree of dissociation. Stoichiometry multiplied by the degree of dissociation. Now Kc, or you can say Kp we are talking about. Let's say we are talking about Kp here. Because according to this reaction dissociates, you can calculate the value of Kp here. Kp is equals to, see, for Kp what you have to do, I'll just do one thing here. sometimes writing is important, na? N2O4, this is 2NO2, because this particular part is very important. This is initially 1, this is initially 0. You dissociate here, let's say alpha amount, 1 into alpha, this is 1 minus 2 alpha will be dissociated. Total number of moles 1 minus alpha plus 2 alpha, this will be 2 alpha only. 1 minus alpha plus 2 alpha, that is going to be 1 plus alpha. These are the total number of moles. So you have to divide it by total number of moles, right? When you divide this by total number of moles, what you will get here? Total number of moles, what you will get here? You will simply get that these are the mole fractions. So you multiply it by the pressure of the vessel, you will get the partial pressure. Now, what is the value of Kp? Kp is equals to NO2, the pressure of NO2, right, raised to power 2 divided by the pressure of N2O4, right? So here you just have to put the values. This is the value of 2 alpha. This is basically you will get this thing here. This is the pressure of NO2. This is the pressure of N2O4. When you put these values here, you will get this expression here. To this, you know the value of alpha, put the value of alpha. Pressure is given to you already, that is 1 atmospheric pressure. So put it 1 atmospheric, you will get the value of Kp as 1 divided by 0.75, that is 4 by 3. Once you get the value of Kp, equilibrium constant you have got, now what you have to do, delta G is equals to minus 2. I'll just write the formula here. Delta G naught is equals to minus 2.303 RT log of Kp or Kc, right? So you'll just have to put the values here and you will get your answer. Okay, everybody, got it? Yes? Okay. Now, I don't know why I don't know if even only I can see the lag or you also can see the lag here. Now next is 1.2 milliliter of acetic acid with density this. When dissolved in 2 liter of water, depression in freezing point observed is this. That means delta TF is given to you, right? I and MF and KF. KF is also given to you, delta TF is also given to you. They are saying consider molality and molarity. This should be molarity. Okay, molarity is same. This means here you can also put the value. This can also be equal to I into capital M into KF. Right? This we can also equate it like this. Now 1.2 milliliter of acetic acid with density this. This is the weight of C. If volume is given, density is given, right? So weight of solute will be equals to density into volume, right? So here you can calculate the weight of the solute, right? When dissolved in 2 liter, so from there molarity will be equals to weight of solute by molar mass of solute multiplied by volume in liters. Volume is given to you. Volume is given to be 2. This is given to be 2. Acetic acid is CH3COH, that is coming out to be around 60, right? W2 you can easily calculate from here. You know the value of molarity also, you know the value of KF also. From here you can calculate the value of I, that is Van Hoff factor. Once you know the value of Van Hoff factor, consider method, report your answer, what they are asking. Find the percentage dissociation. Then we know that number of molecules then it will be dissociated into is going to be CH3COOH give rise to CH3COO negative plus H positive. It is going to dissociate it into 2 moles here. So N is going to equal to 2. What is the formula? Formula is I is equals to 1 plus N minus 1 alpha. I you can calculate from here only from the value of depression in freezing point, you can calculate it, right? This will be molarity. You can just say this is the molarity, and molarity are equal to each other. You can calculate the value of I. After I, put the value of I, put the value of N, you can calculate the value of alpha. Then percentage dissociation will be when you multiply it by 100. So answer will be around 4.93. That is 5 is going to be the correct answer. Got it? Okay. Yes. Now next question here is, Which of the following energy barrier curve represents the following reaction? Okay, so you have NaI here. This is a curve. Acha. So basically, this is nothing but this is Finkelstein reaction. Okay, it's a very, very interesting question. Finkelstein reaction. So in Finkelstein reaction, what you have? In Finkelstein reaction, remember one thing, beta, that is a SN2 reaction. Okay, that means this occurs in one step. Okay. Wait a minute. SN2. SN, just give me a minute, beta. SN1, SN2. Swords reaction. Yes. It is a SN2 reaction which occurs in one step, right? That is why it has the formation of transition state. So as you can see, out of this, there you require only one transition state, which is only possible in case of A graph. This is a graph of SN1 mechanism where you have carbocation formation, right? So answer is going to be A is the correct answer. Next is, in allene, the type of hybridization of carbon atom is. The type of hybridization of carbon atom you are supposed to tell, right? So that is going to be 1, 2, 3. Okay, double bond. Here you have 1, 2, 1, 2. This is H, this is H. These both double bonds are on the perpendicular axis with each other, right? Now they are asking you what is the hybridization. This is sp2, this is sp, this is sp2 because it has 1 sigma, 2 sigma, 3 sigma sp2, 2 sigma sp, again 3 sigma, that is sp2. So answer is it has sp and sp2 hybridization. Okay, those who don't know what is allene, we won't be able to answer this. It's a very easy, good question, right? But I would say you need to have knowledge about it. Which of the following statement is not true about the complex sign? Here where you can stuck is not true, right? And that to the statements are, you have something like this, PT 1, 2, 3, basically octahedral species you have, right? This kind of, where this can be formed, this is Cl, this is Cl, trans, and one cis you can also form one cis here, that is En here, Cl here, Cl here. Now, if you see this here, it has two geometrical isomers. Okay, two geometrical isomers are there. That is definitely true. One is trans, other is cis. That is true, right? Both cis and trans display optical activity. That is not true because optical activity is only shown by, as you can see here, when you have this cis, only then the mirror image is non-superimposable. In this case, the mirror image is superimposable. So it will not show any optical activity. Cis will show optical activity, so both will not show. Only cis shows optical activity. Only the cis isomer has non-superimposable mirror image. That is also true. So incorrect option is B is the incorrect option. Right? Next question is, the dependence of molar conductance. Again, a very interesting question. This graph is given to you, right? As if you directly compare this with y is equals to mx also, y is equals to, this is mx, this is plus c, then c will become the intercept here, right? Now, can you see that this is a graph of weak electrolyte, right? Isn't it? This is a graph of weak electrolyte that shows a straight line graph. So answer is going to be maybe expressed in all. Acha, this is the graph of strong electron. So sorry. Yes, this is the graph of strong electrolyte. If you see this here, you have two kind of graphs that you can have here. This is and this can be your this can be your under root C concentration, right? So basically, what you will see here, that what kind of graph you can have for strong electrolyte is a straight line graph, which will cut and give you the intercept as infinite dilution. But the graph of weak electrolyte is going to be parallel to the y-axis. That is why we have to use Corlosh law to find it. So this is a graph of strong electrolyte. right? So this is strong, this is strong, this is strong, this is not a strong electrolyte, this is a weak electrolyte. So all these things will give this graph except for CH3COH, which is a weak electrolyte, right? Next question is the oxidation state of sulfur atoms in case of Caro's and Marshall's acid. So for this, you need to know the diagrams, the structures of Caro's and Marshall's acid. So in Caro's acid, what you have is, this is the structure of Caro's acid. So this is going to be sulfur. This is -2, this is +2. This is -1, this is +1. -2 +2, -1 +1. So it is total 2, 3, 4, 5, 6. Sulfur is having 6 oxidation state. Similarly, here it is -2 +2, -2 +2, -1 +1, -1 +1. So it is 2, 3, 4, 5, 6. Sulfur is +6 oxidation state. Similarly, here sulfur is +6 oxidation state. So in both the cases, sulfur is having +6 oxidation state. In this case, beta, you should have known the structures of the acids here, Caro's and Marshall's acid, which we usually forget. Now, next is how many pi bonds are present in compound A. In compound A, this is the compound A. Very important. See, as you can see, ozonolysis has happened here. Ozonolysis means you will break the double bond, you will attach double bond O, you will attach double bond O here. Right? That should be the answer here. Now, what you can see here is, this is C double bond O. This is also C double bond O. That means, if you see this structure, this bond and this bond, we have made from a double bond. That means there must be a double bond between this carbon and this carbon, right, which has made this new thing. Already there is a double bond here. Already there is a double bond here. Okay? Now, as you can see, here it is 1, 2, 3, 4, 5, 6. Total only 6 carbons. But initially you have total 12 carbons. That means, can I say, if we are saying that 2 moles of this is formed, 2 moles of this is formed, that means in this molecule you have 2 double bonds. 2 double bonds. Right? Those 2 double bonds will break and they will make 1 double bond O, 1 double bond O, 1 double bond O, 1 double bond O. That is why 2 mole of this means 2 double bond O, 2 moles of this means 2 double bond O. Already you have extra this and this, right? This is also 1, this is also 1, that means 2. And see, this one molecule, basically what I want to say, if you talk about this 1 mole will have 1 double bond O, 1 double bond O. Already it has 2, right? This 1 more molecule will have more 2, right? Then this bond attached to this bond will have 1 more double bond. This 1 molecule attached to this molecule will also have 1 more bond. So totally it will have 6 bonds. Understood how it will have 6 bonds? I'll again explain that. So basically what you have here is, this is 2 mole, this is 2 mole. How it is formed? If you have 2 double bonds in the initial phase. That is why 2 double bonds already you have. Let's add 2 plus this, so we have taken this C double bond O and this C double bond O, you have 2 times in 1 mole. But you have 2 mole of this, that means you will have total 4. So answer will be 6. That means you will have 6 double bonds, 6 pi bonds in this case. Okay? How come it is 4? How many pi bonds are present in compound A? If you talk about, wait a minute, have I written it right? 1, 2, 3, 4. 1, 2, 3, 4, already there. Wait a minute. Wait a minute. Let me just see this. If you talk about this bond with this bond, it will have a double bond, right? Okay. Let's make 2-3 moles here. Let's make the structure only. This is C, this is double bond, this is C, right? So this is CH3. Let's see if there is any structure we can make out of it. This is CH3, this is C double bond, this is C. This double bond we have created, this is COOH, this is COOH. Now they are saying in the original structure, you have 16 of this, right? This is 1 mole you had from here. Okay? Wait a minute. Let's apply some other strategy here. This is CH3, C double bond O, CH3. So this is the one bond with this one. This we have formed already, right? Okay. So already it has attached. Achha. So we can't differentiate that now. We can't differentiate the other molecules because we are using oxidative. We are doing the oxidative ozonolysis. That means this bond is also attached to some bond. This bond is also attached to the some bond, right? This also we have made after ozonolysis only, right? So you can attach all these things here, right? Let's attach because oxidative ozonolysis we are talking about now. So originally you don't have any oxygen here. This I forgot. Originally you don't have any oxygen here. So let's make this. This is 12 carbon, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11, this is 12. Okay. Now here we are saying you have double bond in which area? You have double bond. Firstly in this part. Okay. First I am saying you are having double bond here. Then you are having double bond here. Okay. Double bond in the end. Because this double bond is going to give you CH3C, CH3C double bond O, and then again you need to have one CH3 here, right? One CH3 here, right? And one CH3 here. Okay? So subtract 2 carbons here, right? Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So if you break this bond, okay, this is a very, very interesting question. CH3, this is also CH3. When you break this bond, you will have CH3CO CH3. Here also you will have CH3CO CH3. Okay. Now you have to see what you will get from here. If you have a double bond here, okay, now you need to have 2 moles of COH, C double bond O, COH. For that, this will be COH, C, this will be double bond O, right? Okay, so this will be double bond O, COH, C, double bond O, COH. Okay, 1 bond here, 1, 2, 3, 4. By this, you can have the formation. Okay? If you see this, this will be the actual structure. Okay? This will be the actual structure. Let me just draw this. 1, 2, 3, 4 and this. Wait a minute. Let me just draw that structure. It will be 1 carbon here, right? 1 carbon, and then this is going to be exact means same structure will be there. C, 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 and this is C, 1 carbon, double bond. This is CH3 after leaving 2. Okay, this is CH3 and this is CH3. Okay, I think this is going to be the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Now, if you break this now, you will get the answer. This is CH, 1, 2, 3, CH, this is CH, this is also CH, this is also CH. When you break this now, you will get the answer. How? When you break this, you will get 2 mole of CH3CO CH3, right? When you break this, you will get this particular thing, that is COH. From here you will get COH, C double bond O, COH, COH, C double bond COH. Right? So in originally 1, 2, 3, 4. 4 bonds you will have originally here. Right? Okay? Understood? Yes, everybody. So this will be COH, C double bond O, COH. Right? This is what you will get here. Okay, students? Understood that or not? Okay? So you can also link it here. Okay? By that you will have the formation of 4 moles here. Okay? Wait a minute. Let me just see. Here you are getting CH3, CH3. This you are getting, you break the bond here, you are getting COH only. Okay? 1 mole, 2 mole, 3 mole of COH you are getting. Oh, this is also not the correct answer then. Very complicated question this is, huh? Very complicated. Very complicated. To make the structure, it's very complicated. CH3, C double bond, this is C, right? So let's 1, 2, 3, 4, 8, 9, 10, 11, 12. Okay. Now to get CH3, C double bond O, you have to have one cyclic structure here. Okay? This will not be formed with a simple structure. You need to have a cyclic structure of 1, 2, 3, 4, where you can have this kind of structure, that is C double bond O, right? This should be C double bond O. This is connected to C double bond, that is connected to C. This is also connected to C. This is also connected to C. This is also connected to C. Something like this kind of structure would be there. Okay? So let's not get into that. Otherwise, so it will be very confusing for you to draw the structure only. Let's do what is the easy method of doing this. So easy method is, if you see that this is the first bond that you must have formed, this is the second bond that you must have formed. That means there is one double bond here, right? This also means there is one double bond. This also means there is one double bond, because of which you have linked this thing. Okay, 2 moles of this means one double bond here and here, one double bond of those two here. I'll just write it here. I'll just draw it here. This is C double bond O. This is CH3. This is CH3. This is again COOH. C double bond O. This is COOH. So what you can see here, initially you have no oxygen here, right? That means you can have a reaction, you can have a double bond here, right? You can have a double bond here, right? You can have a double bond between these two C double bond, or you can have a double bond between these two C double bond. That is how you will get 4 double bonds. Okay? Drawing the structure is because there can be like, it will take time to draw the structures. So what you can do here, just write all the things here, just write all the double bonds here. So if you can see here that how you will draw that, how much double bonds you will have. This is CH3, this is C double bond O CH3, this is C double bond O, C double bond O OH, C double bond O, this is C double bond O OH. So this will tell you that these 2 double bonds, these 2 double bonds, these 2 double bonds, and these 2 double bonds. These 2 double bonds we break the, whenever, what is ozonolysis? We break the double bond, we attach double bond O and double bond O. This is what we must have done, right, to get 2 moles of this and 2 moles of this. So that total corresponds to 4 double bonds. So answer, that is why, is 4 double bonds. Okay, got it? So that is the correct answer. Chalo. Let us do the next one, that is a solution of phenols. A solution of phenol in chloroform when treated with aqueous NaOH gives compound P as per major product. The mass percentage of carbon P is. Now let us see the solution here. See, phenol, they have given this random example in chloroform when treated with aqueous, this give a compound P. What is that compound P? According to Reimer-Tiemann reaction, salicylic aldehyde is that compound P. Molecular weight is going to be C7H6O2. Molecular weight is 122 after calculating the molar mass here. They are asking you percentage of carbon. Percentage of carbon is the molar mass of carbon here, that is 12 into 7 divided by the total molar mass of the compound multiplied by 100, that is going to be approximately 69 is the correct answer. Next is liquid A and liquid B forms ideal solution over the entire range of composition at temperature T. Equimolar binary solution of liquid A and B has vapor pressure 45 torr. See, they have given you two liquids A and B over the entire range of composition. Equimolar binary, equimolar means here they will have mole fraction of A is equals to mole fraction of B. Has vapor pressure 45. That means the vapor pressure, not the original, the vapor pressure at that point, the total vapor pressure PT is 45. At the same temperature, a new solution of A and B having mole fraction this respectively. At the same temperature, a new solution of A and okay, 45 at the same time. Okay, they are saying that 45 is the total pressure of the new solution. Okay, respectively. Okay, has vapor pressure of this. Achha, now they are saying at the same temperature, a new solution have the mole fraction this and this respectively, having the vapor pressure this, the value of this. Okay, but firstly they are saying that you have total pressure where equimolar, that means you have your mole fractions are equal. So applying the Raoult's law here, this and this are equal, right? So equal means you can say that if, see, if I am saying this is equal to this, you only have two things here. We know that mole fraction of all the components is unity. So if I say mole fraction of twice of this is 1, so mole fraction of A or mole fraction of B will come out to be 0.5 here, right? That is how you will put the value of mole fraction as 0.5, 0.5 here, right? Now they have given 20, right? Liquid pressure, equimolar pressure, binary A and B, vapor pressure is 45. Okay. Vapor pressure is this, over a binary solution of A and B has pressure this. At the same temperature, new solution. Acha, they have given this in the bracket. This is what I was thinking, where they have given this. Right, vapor pressure of pure liquid is given to be 20. Right, A is given to be 20. From here, you can calculate this total. Already it is given to you in the question. As you can see here, it is given in the question. Total is 45. Right, so from here you can calculate the pure vapor pressure of B, right? Then they are saying at the same temperature. Now next line is at the same temperature, when the vapor pressure of that solution becomes 22, this is PT dash, when it becomes 22.5, at that case, what is the ratio of mole fraction of A and B? That means here the total, again in a different case, the total pressure is 22.5. Now pressure of original, pure solvent vapor pressure is going to remain same only, that is 20 here and this is 70 here. Now you just solve it for anything, either mole fraction of A or mole fraction of B. You calculate this. We have solved the mole fraction of A here coming out to be 0.95. Then subtract subtract it from 1. You will get the mole fraction of B. Taking the ratio here, it will come out to be 19. Okay. Next is, according to the molecular orbital theory, the bond order of Li positive, Li2 positive is X and Li2 negative is Y. Calculate X plus Y. Now, lithium is nothing but it is hydrogen, helium, lithium, it is 3. 3 into 2 is 6. Right? 6 minus 1 is going to be 5. So, it is 2, 2 and 1 electron. Right? Talking about Li2 negative, that is 6 plus 1. So, it is 2, 2, 2 and 1. Now, talking about the bond order here, it is going to be bonding minus anti-bonding. So, it is 3 minus 2 divided by 2, that is half. It is 1 to 4 minus 3 divided by 2, that is half. Right? So, X plus Y, it is going to be 1 here. Right? X plus Y, it is going to be 1 here. Okay? Chal. Next is how many of the following are elimination reactions majorly? That's a very, very interesting question. Why? Because you have to see how many of the following are elimination reactions here, right? So let us see that. Firstly, as you can see, out of first and second, right, because of the steric factors, this is going to show elimination reaction, right? Then because of the, see, why this is not showing, this is showing again because of the steric factors, right? Here, this is a strong base, so it can show elimination. This is a heavy base, it will show elimination, right? Mm, this will also show elimination reaction. Wait a minute. A, B, C, this is, will show. Then this will not show. ETO will also show the elimination reaction. This also will show the elimination reaction. So according to me, it's B, C, D, E, G. 5 will show the elimination reaction. Let us see. B, C, D, E, and G. Yes, all of them are showing elimination reaction. Okay, for this you need to have a knowledge about reagent. This is a very strong base. This is a very heavy base. This is also a heavy base. Here, because of the Me3, 3 plus side donating groups here, and moreover, it is on this position, not on this position. That is why, because of the steric factor, this position it shows elimination reaction, which is more towards, like more sensitive towards elimination reaction. This is also heavy, that is why it will show the elimination reaction. Okay, as you can see, diaxial existence of this encourages beta hydrogen elimination, right? But in di-equatorial conformation, in which there is no availability of suitable hydrogen for the elimination, okay, because of the axial and equatorial positions, right? Diaxial position, it can show the elimination. So answer is 5. Last question of today, beta, we have is match the following. Again, interesting question. Lot of brain you have to use here. Like P and Cl, which of the following properties are correct? Okay, so I'll directly jump to the answer here, because see, if you talk about the size here, right, let us see all the properties here. In general, size of the atom increases. Now, we know that according to size, all of these are the correct. So, PCl, P is greater than Cl, right? Here we have P is less than Cl, so this is not falling. But all the other properties are correct. If you talk about electronegativity, chlorine is greater. If you talk about ionization, chlorine is greater. Electroaffinity, chlorine is greater. Non-metallic character, chlorine is greater. So, for A, Q, R, S, T are the correct. Q, R, S, T are the correct. From there only you will get the answer A as the correct answer. For B, P and R are correct. B is, if you talk about B here, beryllium is greater than boron. But here, what they are saying is beryllium should be greater. Size is greater and ionization energy is greater, right? Okay, that is an exception because of the half filled, not half filled, because of the fully filled orbital, it has greater ionization energy. Then all of them are less. Others we have less. So that is why only R, P and R are the correct things, right? Next is sulfur and oxygen. Talking about sulfur and oxygen, always what you have, size here they are saying it should be greater. So size of sulfur is greater, definitely right. But if you talk about electronegativity, that is of oxygen is greater, right? Then ionization energy of oxygen is greater. Then talking about the electron affinity, that is of sulfur is greater. Why? Because oxygen has lone pair electrons on it. So because of the repulsions of electronic repulsion, it is very difficult to gain the electron, right? Then non-metallic character of oxygen is more, right? Okay. Now, next is, that is why for only C, P and S are right. P and S means size and electron affinity is right. For lithium and fluorine, you can see that here they are saying that lithium should be less than fluorine. So in this case, what you have, if you talk about lithium and fluorine, definitely electronegativity of fluorine is greater. But if you talk about the size of lithium is greater. Fluorine is the smallest, right? From there only you can get an idea. Ionization enthalpy of, from fluorine, it is very, very difficult to take out the electron because it is highly electronegative. And fluorine also have greater, wait a minute, increases from left to right. Wait a minute, affinity of, acha. So this is electron affinity of fluorine is greater. Wait a minute. Here, non-metallic character of fluorine is greater, right? So for this is fluorine is greater, na? Yes. So it is QRST, QRS and T, four things. Okay? So again, that is the correct answer. So basically, why I picked out this question, because as you can see now, from just one question, they are asking you not one, not two, they are asking you five properties of four comparisons, right? Five properties, four comparison. High chances are that you can do the mistake. But even if you know only the properties of phosphorus and chlorine, even then you could have answered it correctly, right? Okay, so that is a needed thing here. Okay, ji? Got it? Now, beta, these kind of questions now we are taking up in our batches, right? The batch has already started from 12th of March, right? Which you have targeted revision speed and accuracy boost is there. We take quizzes, regular lectures you have here. You have mock tests and analysis, smart practices there in the class itself. Total, you have around 4 sessions in the class starting from 3 p.m. to 10 p.m. onwards, right? And here you have all the things what you require in class: doubt solving, previous year question discussion, practice question discussion. After the class, you get pedagogy, V-Buddy, you get Telegram group here in which you can ask your queries, everything. Handwritten notes are also provided to you. Telegram group is specially for the students who are enrolled into the batch. Now we have majorly three courses here. Ouch. Three courses here. One is your Crash Pro batch, where you have, let's say you have JEE batch, VIT-EEE batch, you have KCET and Comet K test series also. Along with that, you have previous year question book also that will be delivered at your home, right? Then if you go for Crash Combo, if you already have previous year question book, then go for Crash Combo, where you have JEE batch, VIT-EEE batch, KCET and Comet K test. And if you go for Simple Crash, here you have JEE and VIT-EEE classes. Right, so choice is yours. The price I have already mentioned it here: 999, 1999, and 2999. So I think this is a very good option, because you also get previous year question test, previous year question of physics, chemistry, mathematics book delivered at your home, and you also get the test series of KCT and Comet K along with the JEE and VIT-EEE batch. So I think that is great at this price. Okay, and if you only want to purchase, right, let's say, see, if you have already enrolled to this batch, you can also upgrade yourself. But if you only want to purchase the previous year question book, that is at 999, that will be available to you. You can go and check out the link that is mentioned below. Okay, yes, everybody. So that is all about today. Now I want all of you to practice it, and let me know in the comment section if you want me to take up one lecture on physical chemistry, one lecture on inorganic chemistry, one lecture on organic chemistry. I'll take the classes according to the demand. So I want to know in the comment section if there is any demand regarding these three classes differently. Okay, let me know in the comment section. I'll be waiting for your comments. Okay, yes. Okay then, bye bye. Take care. See you all in the next class. Till then, bye bye.